Welcome to another Innovation Coffee Break video. My name is Rushi Dave and I am a development engineer at DSpace. Today's topic is FPGA-based solution libraries provided by DSpace. These libraries contain pre-designed complex arithmetic blocks and input-output functions. Let's take field-oriented control of PMSM in DQ coordinate frame as an example simulation application. This is the application which we want to implement on an FPGA. In order to implement such a complex algorithm, DSpace provides various set of FPGA-based libraries. This can be used in a drag and drop manner. This saves a lot of time and effort on the development side of the team. In order to open any of the FPGA-based libraries, you just type the name of that library in the command window. And the library would open. This is our standard interface. When you click, for example, this is our XSUtils library. And when you click on the FPGA block, you can see all the functions that are provided by XSUtils library. Similarly, we have XSG ACMC library, which has similar interface as the one before. And when we click on FPGA, we can find all the functions that are provided by this library. In case if I want to implement a controller in my working project, I click on controller and I see here a PMSM DQ current controller. Now let's move to our working project. As an example, we take a permanent magnet synchronous machine current controller model from XSG ACMC or XSG AC motor control library and drag it onto our working project. This component is in floating point implemented. In order to generate interfaces which would allow for online tunability in control desk and information exchange between processor and FPGA, we use something called automatic interface generation. This feature is available on all XSG libraries. By opening the component mask, we can navigate to the interface tab. Here we see that it has a GUI supports option. When we go to GUI support option, we can select the FPGA or the target FPGA architecture and the task ID. The result is the interface that allows for data exchange from and to the FPGA as well as within the FPGA. Here we can see the registers that are generated. Finally, using a shortcut known as Ctrl-Alt F9, we connect all the buffer access go-to blocks and the buffer access from blocks. This can be done by going to Tools, going to Solutions, and here you can find the shortcut. Here I have a demo showing how various components from different XSG libraries can be interconnected seamlessly in order to implement a field-oriented control of permanent magnet synchronous machine. As shown, we have a processor side which is sampling at 1 kHz and we have a FPGA side which is sampling at 125 MHz. On the controller side, we have our PMSM DQ current controller from XSG AC motor control library, similarly space vector modulation. And from XSUtils library, we have 3-phase PWM generator. On motor side, we have a PMSM implemented from XSG electric components. Additionally, SENT protocol and SPI protocol are also implemented to transfer data such as torque and DC link voltage. This diagram gives an overview of the motor control which is implemented using FPGA-based solution library provided by DSpace. From SENT library, we are using SENT protocol, and from SPI, XSG SPI library, we are using SPI master and slave protocol. From XSG AC motor control library, we are using DQ-based PMSM current controller, space vector modulation, and resolver RCP. We can see that DQ-based PMSM controller and space vector modulation both are implemented in floating point arithmetic, whereas resolver RCP is implemented in fixed point arithmetic. From XSG electric components library, PMSM, DCM inverter, mechanic, and resolver are implemented. And last, from XSUtils library, general functions such as 3-phase PWM generator and Park-Clark transformation blocks are used. Let's move to Control Desk, where we can visualize the performance of our implemented controller in real time. By changing the current set point, let's say from 50 ampere to 100 ampere, we can see how a controller has reacted. When we move to current controller layout, we can tune the PI control parameters and play around with different values. Using FPGA scope, we can visualize the signals with higher resolutions, which can be useful when trying to study transient response or current ripple. When moving to protocol layout, we can see how send protocol is used in order to transfer torque data. When we again change the current set points from 50 to 100, from 100 to 50 ampere, we can see that the torque measurement has changed. Similarly, SPI protocol allows us for transferring DC link voltage. In a nutshell, DSpace FPGA-based solution offers many advantages, such as seamless inter-library integration in Simulink, online parameter tunability using Control Desk, and real-time performance monitoring using FPGA scopes. All the concepts and functions are implemented to be used on FPGA. This library also provides a wide range of components that allows for implementing large domain of applications. For faster implementation during development phase, automatic interface generation feature is provided. Nothing is hidden. It is possible to look under the mask of every block. FPGA implementation allows for quicker task around time, greater flexibility from logic complexity and development point of view. For higher scalability, floating point implementation is also supported. If you have any questions about this topic, feel free to contact us at any time. Thanks for watching.
DSpace, your partner in simulation and validation.